Okay, this is College Algebra 2.5 homework help. First problem wants us to shift this function 4 units up. To do that, we do 5dx plus 4. Now, I have on the formula sheet you subtract 4 from y, like from the other side, but you could just move that over as 4. I'll show you the formula sheet real quick. So this is on the formula sheet that is on the website. I give you all the information basically. So for a vertical shift, I say subtract from y, it goes up. But like I just said, if you subtract from y, if it's f of x or y, doesn't matter, y minus 4 equals 5 to the x, well then you could add 4 over. And then you get this. So I don't know why I did it backwards, but I guess I tried to stay consistent with x and y. Because if you, the next one, if you shift the function 5 units left, you would add, so it'd be x plus 5, but you'd have to add to x. And that's right in the formula sheet. So I won't bother showing you this every time, but it says subtract from x moves right, add to x it moves left. So, sorry about that. If it adds to x, you move left. Okay, reflecting about the y-axis then. When you reflect about the y-axis, if you look at this, this is x and y, and this is negative x and y. So you just need to change the value on the x right here. So it'd be 5 to the negative x would reflect it across the y. And then the last one, reflecting this around the line x equals 4. Well, let's take a look at this real quick. If this is the function, by the way, it looks like this. If you reflect it over the line x equals 4, 1, 2, 3, 4, this is a really tricky one. And I don't think I'll ask you problems harder than test, but here's 4. Yeah, this. It looks like this. Okay, now, you'd actually have to do the reflection first. You have to reflect this over the y-axis, which we know would change the sign in x. And then you'd get this function right here in purple. Go down like that. And then you have to shift it back. You have to shift it back. And this is really tricky, but 8 units you'd have to go back. And the reason why is because this point right here goes over 4 to get to the reflection line, so it's got to be 4 more to get to the actual function. So they actually, you got to take this purple one now and shift it 8 units to the right. So it's going to be 5 to the negative x, and then 8 to the right means you subtract 8. So this negative sign takes care of the reflection, and then this minus 8 moves it back 8 units. It's a tough problem. Next one's a little easier. We're subtracting from x, so when we compare it to its parent function, if you subtract 2, it moves it to the right, so that's shifted right. I guess I should say 2 units to the right. Positive means right. And then vertically, it's shifted negative 3 units vertically. That means down 3 units. Okay, next one wants us to give, problem 3, wants us to give the equation for this. So I'm going to use y equals a times x minus h squared plus k, where the vertex is at 3, negative 2, so that's important. 3, negative 2 is the vertex because that's h, so x minus 3, and then minus 2. K is negative 2. Now I still have to find a. In order to find, I'm going to use a point. It doesn't matter what point, but I'm going to choose, well, I'm not sure what I'm going to choose. And I guess it's 1. You can always just try this to see if it's 1. I didn't find a whole number this graph goes through, so I didn't think that it'd be that easy. Basically, I guess this is 1.1, 2, 3, 4, 5. So 1.6. This if it goes by 2s, 2, 4, 6, 8, 10. So I guess I could have plugged in 1.6 for x, and then 0 for y, and that should give me 1 right here. So that's one way to check it. But I just guessed. I just said, okay, well it's probably 1. Try that, and that worked. All right, the next problem is an absolute value function. We know the parent absolute value function looks like this. The branches have a slope of 1, just like this one does. This one goes up 1 over 1. But it's been shifted back 2 units and down 1. So we need to write that into our formula. Back 2 units means that we add to x, so it'll be x plus 2. And we'll move to the left. And then also, if we subtract 1 outside, this will move it down 1. All right, the next problem wants us to take the sine function, the parent function, and it says the graphs have been changed in what way? Well, let's take a look at the first one. The first one's been down, shifted down 16 units, so let's look for that. Shifted 16 units down would be D. The next one, then we're taking the function dividing by 16, so it's y equals sine of x divided by 16. That's on the formula sheet right here. It's a little confusing, but basically it says for vertical stretch, if we divide y by a number bigger than 1, it's a stretch. If we divide y by a number between 0 and 1, it's a shrink. So I'm going to move this over and make it 16y equals sine of x. And then that's really y divided by 1 over 16 is another way I can write it, right? Because multiplying by a number assumes divided by the reciprocal. So then I can compare it to what I have in the formula sheet, which is that if I divide y by a number between 0 and 1, it's a vertical shrink. So this is a vertical shrink. So let's look for that. Compressed vertically by a factor of 16 would be C. So I know it's written a little bit weird, but you can do it different ways, but I like to stay consistent with x and y, so that's the way I put it on the formula sheet. If you like it a different way, then feel free to do it whatever way makes sense to you. But the next one, 16x, that's actually the same thing now, a little confusing, but if I can write that as 16 over, x over 1 divided by 16, that's the same thing, because multiplying by a number same as divided by a reciprocal. And then on the formula sheet, it says if I divide x by a number between 0 and 1, it's a horizontal shrink. So that would be a horizontal shrink, compressed horizontally by a factor of 16. Which leaves the last one then, the only available choice left, which is B, which is stretched horizontally. And if you divide y by a number bigger than 1, it is a horizontal stretch. Next problem, same thing. If I add to x, that shifts it to the left. If I add outside of x right there, that shifts it up. The graph of 98 can be obtained. If I divide this to both sides, I'm dividing y by a number bigger than 1. So on the formula sheet, if I divide y by a number bigger than 1, it's a vertical stretch. So I would say stretching, maybe. And then the graph of this can be obtained by multiplying x is the same thing as dividing by 1 over 98. And on the formula sheet, that's dividing x by a number between 0 and 1, which is a shrink. So I would say shrinking. The next problem says wants to take this parent function, f of x. We're going to call the new one g of x though. And what we're going to do to it is we're going to shift it to the left, so that'd be x plus 76. And then we're going to shrink it vertically. Shrinking it vertically is dividing y by 1 over 39. I'm going to multiply that by both sides. And then the last thing we're going to do is shift it downward, so move this down to 73. So there's our new function. Okay, the next one says, take a look at this parent function and then label each of these below. So f of x, well, that's b. That's the normal square root function. So I'd say b for that one. 4 times f of x. Now, if I divide that from both sides on the formula sheet, you're dividing y by a number bigger than 4. So, I guess it's most helpful to look at it like this. G of x equals 4 times the original function. Divide that by 4, so that'd be a stretch. So that'd be the bigger one up here, C. If I divide y by a number bigger than 1 on the formula sheet, that's a stretch right here. Okay, so then the last one is if I multiply by a negative 1/2, that is, the reflection happens first, so that reflects it over the x-axis, and it'd be like here. And then I have to figure out whether it's shrinked or stretched from there. So if I divide both sides, you know, same thing, it's like I have this now, negative 1/2. I've already taken care of the negative. But if I divide by a fraction, if we divide by a number between 0 and 1, it's a vertical shrink. So that thing's shrunk down, so it should be E. This was C. And then the last one, negative 5, so that's reflected over, but then dividing by a number bigger than 1 is the vertical stretch, so that would be F, this green one. And this looked like a B, but apparently that's a D right there for the first one, so apparently this is a D. Okay, next problem, the parent function is this x to the 1.5, right there. If we subtract 1, we move it down, so that'd just be B. And then if we subtract 1 from x, that moves it to the right. So that would be something like C. And then if we do 1 minus, we're actually, I'm going to rewrite that as negative x to the 3/2 plus 1, because it's shifted up, but it's reflected first. So first it's reflected over the y-axis. And then once it's reflected, then it's shifted up 1 unit. So it's the green function, which is d. And the last one, this is multiplying by 3/2. So I'm going to divide y by 3/2, which is a number bigger than 1. So if we divide y by a number bigger than 1, it's a vertical stretch. That one's been stretched vertically. So if you look for one that's a little steeper, that'd be this A1. This one's a little tricky. You have to rearrange it so you get y equals 2 plus 5 plus 5e to the negative x. All I did was distribute the 5 to both these terms. And then I'm going to rearrange it as 5e to the x plus 7. So this thing has been, this 5 right here is basically like a vertical stretch because I'm dividing y by a number bigger than 1. So it's been vertically stretched by a factor of 5, and it's been shifted up 7 units. So vertically stretched by a factor of 5 shifted up would be C for me. And the last problem then, starting with this graph, this is write the equation if we were to shift it 2 units downward. 2 units downward would be y equals 3x and then minus 2. The next one, shift it 2 units to the right. 2 units to the right is when we subtract 2 from x. Okay, and the next one, reflecting about the x-axis. Keep in mind when you reflect about the x-axis, you're changing the sign on y because it's the point xy, and this is the point x negative y. So you need to flip the sign on y, which you can move over to the right side as y equals negative 3 to the x. All right, reflecting about the y-axis though moves the point over here, which flip the sign on x. So that'd be y equals 3 to the negative x. And the last one, reflecting about the x-axis and the y-axis, would change the sign on both to be negative 3 to the negative x. All right, hope this